So in this video we're going to talk about how to sketch an angle in standard position. So before we try sketching one in standard position, we need to know what standard position means. And all standard position means is to establish your angle in the XY plane. So here's my Y-axis, here's my X-axis. Be sure to put the vertex at the origin. So put the vertex of the angle at the origin and put that initial side of the angle on the positive x-axis. And then from there you rotate either counterclockwise or clockwise to some terminal point or some terminal side of the angle. So in this case I have a 50-degree angle. So I've set the vertex at the origin, established a ray on the positive x-axis. I have rotated through to a terminal side of that angle. So there is a 50-degree angle drawn in standard position. We could have done a coterminal angle with that. We could have said, hey, let's start at the initial side on the positive x-axis and rotate counterclockwise. And that angle would also be an angle in standard position. And to find that angle, we would just take 50 degrees minus 1 times 360 degrees. So we're doing one reverse rotation, which would give us an angle of negative 310 degrees. So this is a negative 310 degree angle in standard position. Here's a quadrant 2 standard position angle, vertex at the origin, initial side on the positive x-axis, and we've rotated through by 140 degrees to the terminal side of the angle. That's 140 degrees. I know it's difficult to see. We could have over-rotated. We could have said, hey, let's do 140 degrees plus, let's find a coterminal angle. Let's say 1 times 360 degrees, which is going to be 500 degrees. So we could have said start at the initial position, rotate 360 degrees plus an additional 140 degrees. So that would be a 500 degree angle written in standard position. So in each of these 4 examples we have an angle in standard position because the vertex of the angle is at the origin, the initial side is on the positive x-axis, and we've rotated through to some terminal side. Again, we can do multiple rotations, that's okay. We can do counterclockwise rotations as well, and that's okay. The only stipulation we have to be in standard position is vertex at the origin, initial side on the positive x-axis, rotate through clockwise or counterclockwise, and we've got a standard position angle. So if we're sketching an angle in standard position, we start with an angle. If we don't have an angle that's between 0 and 360 degrees, what we want to do first is find a coterminal angle theta that is between 0 and 360 degrees. And what we'll do is sketch that angle and then use it to help us sketch the angle that we really want to sketch. So a 480 degree angle is not between 0 and 360, but I see that if I take 480 degrees and I subtract 1 times 360 degrees from it, I subtract 1 full rotation, I get a 120 degree angle, which is partway between 90 degrees and 180 degrees. In fact, 120 is, if we think about it, just 30 degrees past the 90 degree position. So I start with my vertex at the origin, I draw a ray in standard position, and then I draw a ray that is approximately, to the eyeball, 30 degrees past the 90 degree position. And now to get my 480 degree angle, I'm going to say, well, this is a full 360 plus an additional 120. To get there, this is a 480 degree angle in standard position. Here I have a negative 390 degree angle, so I want to sketch it in standard position. I'm going to establish my vertex at the origin, my initial side on the positive x-axis, and then I'm going to find an angle that is coterminal with it, but that is between 0 and 360. So I'm going to add 2 360 degree revolutions to this, which is going to give me, when I crunch this out, it's going to give me a 330 degree angle, which is 30 degrees short of being 360. So if I'll make this look like 30 degrees, it'd be 330 degrees to here plus an additional 30 to get a full 360 degree rotation. But the angle I want to sketch is negative 390, so I'm going to start on the positive x-axis. I'm going to do my clockwise rotation because of the negative sign. The full 360 plus another negative 30 gives me a negative 390 degree angle in standard position. So here's a couple of examples where the angles are instead in radians. And if you're working in radians and there's a pi in the numerator, which there are in both of these cases. In fact, the angles pi over 3, pi over 4, pi over 6 are going to be important in trigonometry, and we're going to see that in the next lesson when we work with special angles and the unit circle. So kind of on purpose, these examples have a 4 and a 3 in the denominator. When you sketch these, the idea is ignore the 5 and just look at the pi over 3 and think about what that's telling us. Pi, radians by itself, is equivalent to a 180 degree rotation, right? So it's the upper half plane, it's the upper xy plane. And this division by 3 is saying take the upper half plane and divide it into 3 chunks, 360 degree chunks, right? So take pi radians, divide it into 3 equal sized pieces. Those are going to be 60 degree sized pieces. So if I make an angle that looks like about 60, another 60 degrees over to here, 60 degrees between here and here, another 60 degrees through to here, another 60 degrees, another 60 degrees. So we do 60 times 1, 2, 3, 4, 5, 6. We get 60 times 6 is the full 360 degrees. And once we use this to chunk the upper half plane into 3 equal sized chunks, this tells us, hey, count out 5 of those pieces. So count. Start on the positive x-axis. Say it's going to be 1, 2, 3, 4, 5. And there is my 5 pi over 3 angle in standard position. So I could play the same type of game over here. I could say, let's ignore the negative 3 for a moment. The negative we know is going to produce a clockwise rotation some number of times. And just focus on the fact that we have a pi in the numerator and it's being divided into 4 pieces. So pi is 180 degrees. Pi is equivalent to 180 degrees, and if we're dividing that into 4 pieces, what's that going to give us? Well, 4 goes into 180, 45 times, so pi over 4 is a 45 degree chunk. So I'm going to chunk the upper half plane, I'm going to chunk a rotation of pi, which is the upper half, into 4 45 degree chunks. And I could pull these through and chunk everything else up as well. So I wind up with 8 slices, each of which is 45 degrees. 45 times 8 will be 360 degrees, the full revolution. And then this says do negative 3 of those. So establish my initial side on the positive x-axis and count. Negative 1, negative 2, negative 3. There it is. And now these other guys were just there help me draw, and I'll get rid of those. And there is a negative 3 pi over 4 angle in standard position.